Today we will review all of the lessons in Pearson Topic 9. Let's begin with Topic 9-1. I know that you can add and subtract algorithms very easily. However, sometimes it's necessary to show your work. Let's just use this example problem to review how to show your work with a picture. Our equation is 34 minus 6 equals, and we're looking for the difference for this question. First of all, we have 3 tens and 4 ones. We need to subtract 6 ones. Of course, 4 ones cannot subtract 6 ones. So we need to regroup one of the tens. Now we have 2 tens, and this group has been exchanged into 10 ones. So we have a total of 14 ones. 2 tens, 14 ones. It's still 34. We're now able to subtract our ones. We need to subtract 6 of them. And you can see that they're X'd out in this picture. We're left with 2 tens and 8 ones. So 34 minus 6 equals 28. Lesson 9-2 builds on that picture concept that we just discussed previously. Our next question is 32 minus 5. You can see the picture representation here. Now we see the algorithm format. Again, 2 ones is not sufficient to subtract 5 ones. So the regrouping takes place again. One of the tens is exchanged for 10 ones. So now we have 2 tens and 12 ones. You can see that the algorithm is formatted here, showing the 2 tens and 12 ones. We can now subtract. As previously in lesson 9-1, the ones are X'd out to show the remaining number that are available. We see the algorithm here, 12 subtracting 5 would leave us with 7. Now it's time that we can turn our attention to the tens column. We have 2 tens that are not subtracting any additional number. So we have 2 in the tens column. So 32 minus 5, the difference is 27. Topic 9-3 eliminates the illustration or picture format, and just the algorithm remains. So for this example, we are subtracting 9 from 42. So 42 minus 9, we're looking for the difference. Again, we see that 2 ones cannot subtract 9 ones. So regrouping is necessary. Here is our next step. We regroup one of the tens, which will then leave us with 3 tens. And now we have 12 ones. The 10 that we regrouped is 10 ones plus the 2 ones that we already had. So 12 ones can now subtract 9 ones. And we see in this next step, 12 minus 9 equals 3. We're now ready to work with the tens column. There were 3 tens, and we are not subtracting any additional number. So we have 3 tens in the tens column. So 42 minus 9 equals 33. The difference of 42 minus 9 is 33. Lesson 9-4 continues with the same basic concept. Now, though, we have 2 two-digit numbers. We're subtracting a 2-digit number from a 2-digit number. For this example, we are subtracting 31 minus 14. So we have the picture representation again with 3 tens and 1 1. Again, when we put it in algorithm format, it's very easy to see that 1 1 cannot subtract 4 ones. So we need to regroup, of course. So with our 3 tens, we regroup one of them into 10 ones. Now we have 2 tens and 11 ones. We're ready to do our subtraction. So coming to this next picture example, we have 11 ones and we're subtracting 4 ones. You can see that they are crossed out, leaving the remaining ones. There are 7. Moving to the tens column, we have 2 tens subtracting 1 10. 1 10 is crossed out with a remaining 10. So 31 minus 14 equals 17. 31 minus 14 equals 17. The difference is 17. You are very capable mathematicians. 9-5 just removes the picture representation. So now our equation will be 43 minus 18 equals. The frame is put here for you to help you keep track of your numbers. You are very good at doing that already, but we'll just practice because it's a good habit to continue to practice and make sure that your columns are straight. The tens are in the tens, the ones are in the ones. So now we see 43 minus 18 in the frame. 3 cannot subtract 8. So again, we must regroup. We change one of the tens into 10 ones. So now we have 13 ones and 3 tens. That still equals 43. We've just regrouped the number, but it enables us to subtract. 13 ones minus 8 ones equals 5 ones. Moving to the tens column, 3 tens minus 1 10 is 2 tens. So the answer, or the difference of 43 minus 18 is 25. 43 minus 18 equals 25. The equation is complete. You know, lesson 9-7 was not my favorite. However, it's good to be able to show a variety of ways to show subtraction and allow people to understand your thinking. So on a number line, we have 27 and we're subtracting 15. So the suggestion is to use one color, and starting at 0, we will move to the number 27. Next step, from the 27, we must now count backwards toward 0, 15 spaces. And at that point, we reach the number 12, and you can see it's circled here. So 27, the purple arrow, subtracting 15, the orange arrow, leaves us at point 12 on the number line. Lesson 9-7 is not a new concept for you. You have been checking your subtraction with addition since the beginning of the year. But for practice purposes, we'll discuss that concept one more time. So the problem has been completed for you. 24 minus 9 equals 15. The next step is to check with addition. So our difference, which is 15, is added to the subtrahend, which is 9. And when the difference and the subtrahend are added together, we find the minuend. The minuend was 24. 24 minus 9 equals 15. 15 plus 9 equals 24. This would be part of a fact family, and we've used that before. So in our rectangle, partitioned rectangle here, we see that if 9 is added to 15, the total will be 24. Another example, the same idea. The minuend is 52. The subtrahend is 17. The difference is 35. 52 minus 17 is 35. You can see that regrouping was necessary on this problem. The checking with addition is the same exact concept. We take the difference of 35, add it to the subtrahend, and then we will find the minuend. So the sum in addition will be the minuend of subtraction. Again, a partitioned rectangle. 17 plus 35 will give you a total of 52. The answer is correct. Lesson 9-8 provided a variety of ways that you could complete your work. You have a lot of tools that you can use depending on the situation. You know how to use mental math when the numbers are simplistic and easy, that you can just find the answer mentally without any paper or pencil. If a problem is difficulty or you need to show your work, cubes are always a good choice. You might use paper and pencil and complete an algorithm, which you are very capable of doing. A choice is given to use a calculator. At this point in time, I don't believe a calculator is your best choice. If you're working with extremely large numbers, then it might be a choice that could be used. But at this point in time, a calculator is not our best choice. The final lesson is 9-9, and the topic is two-part problems. So reading this problem, we know that we're going to have to figure out step 1 before we can answer the second question. So Mia sees 15 yellow birds and 16 red birds. How many birds does she see in all? Then 17 birds fly away. How many birds are left? Of course, we need to answer the first question in order to answer the second question. So first of all, Mia saw 15 yellow birds, 16 red birds. She saw a total of 31 birds. 15 plus 16 is 31. It's a near double, if you'll notice. So there were 31 birds. However, 17 of them flew away. The remaining number of birds was 14. You can do this algorithm very simply. 31 minus 17 equals 14. You know how to regroup the numbers very well. So 31 minus 17 is 14. The first question, Mia sees 31 birds in all. There are 14 birds left after 17 fly away. So be sure you're careful that you read the question and answer properly. With patience and working thoughtfully, you can answer all of these questions 100% of the time. That concludes today's review of Pearson 2nd grade, topic 9.